So let's take a look at this question, which is asking us to perform a hypothesis test for correlation between two data sets. So this question says the table below, which is going to be right here under this little blue table icon, the table below includes data from taxi rides. The distance are in miles, the times are in minutes, the fares are in dollars, and the tips are in dollars. Is there sufficient evidence to conclude that there is a linear correlation between the time of the ride and the tip amount? In other words, is the time you're taking the ride in the taxi influencing how much you are tipping the driver? So like if you take a ride later in the evening, are you tipping more or are you tipping less, for example? Construct a scatterplot, find the value of the linear correlation coefficient R, and find the p-value of R. Determine whether there is sufficient evidence to support a claim of linear correlation between the two variables. Use a significance level of alpha equals 0.01. Does it appear that riders base their tips on the time of the ride? So all of this is going to be based on the data that is here under this table. So if we click the little blue icon, we're going to open up the data that again had the distance of the ride, the time of the ride, the fare that was charged for the ride, and the tip amount. This question is only asking us about the time of the ride and the tip amount. So we're just going to be focused on this second row here for time and this tip amount in the fourth row. So let's go ahead and open this in StatCrunch. We're going to do that by clicking the little blue icon in the corner and then selecting Open in StatCrunch. Once we get this open, the first thing we notice with this problem, which will not be the case in every problem, is that the data is given in rows, right? The distance is all across here given in this row format. The time is in a row, the fare is in a row, the tips are in a row. So when we use StatCrunch to make calculations for linear regression or linear correlation, we really need the data to be presented as columns rather than rows. They need to be going up and down. So luckily we have a nice easy way in StatCrunch to change the presentation of this data so it can be in columns instead of rows. To do that, we're just going to go to Data at the top, and then we're going to go to Arrange, and then we're going to select Transpose. That's going to take the data and change it from being presented in rows to being presented in columns. So we want to select all the different columns to transpose because we don't want to leave anything out. The best way to do that is just to click your cursor into the section that says Select Columns, and then on your keyboard, if you hit Control and the letter A key, it should select everything all at once. You can just click Compute right here if you want, and then this transposed information will appear in the same spreadsheet that you were already in, or you can click Open in New Data Table to have it in a new fresh data table without anything else in it. I'm going to select that option and then we'll click Compute. And in a new table, we now have all this same data presented in columns. The distance is in column, time, fare, and tip are all in columns. So again, the first thing we were asked to do here was to construct a scatter plot. So basically all the information we need for this question is going to be found through one shot in StatCrunch. We're going to go ahead and go to Stat, Regression, Simple Linear. When this opens, we need to tell StatCrunch which two columns we want to compare. Again, for this question, they were asking us to compare the time of the ride to the tip amount. So for the X variable, we're going to choose the time, and for the Y variable, we're going to choose the tip. We can leave everything else the same. We want it to be checked as hypothesis test with zeros entered everywhere here. Down at the bottom, we're going to go ahead and click Compute. And we're going to get a lot of numbers right here, which we'll use in a minute. But for the scatter plot, if we just click the arrow going to the right, we will get a scatter plot for this data. And we can now use this scatter plot to compare to the four options that we had in my math lab. Here's a side-by-side view of the scatter plot that we just got in StatCrunch and the four options for the graphs that we received in my math lab to choose between. So Through a little bit of process of elimination, we can go ahead and figure out which of these 4 graphs in my math lab is matching with the way the dots are arranged in the graph that we got from StatCrunch. Now notice they're a little bit different because the scales are different, right? In my math lab, all the graphs on the horizontal axis, on the x-axis, are going from 0 to 35, and on the vertical axis, they're going from 0 to 25. Notice that's the same for all 4 of the options. But that's not what we have over here. Over here, we're going from 0 to 30 on the x-axis and 0 to only 4 on the y-axis. So these are not really apples to apples comparable right now, but we can go ahead and change that. If we click this little 3-bar button right here in the bottom left corner, we can go to the x-axis and we can change that to start at 0 and to end at 35, the same way we had in my math lab. And likewise, we can go to the y-axis and have that start at 0 and end at 25. So now the graph that we have here is actually comparable on the same scale to the scales that we have over here. And if you just look across, if it's hard to see, you can click on these little magnifying glasses to blow up the graph so you can see them in a little bit more detail. But eventually, after you compare them all, you will see that letter B is the option that has all the dots in the same pattern as we see over here. So the correct scatter plot is B. Let's make this a little bigger now so we can see the whole problem again. So the next thing we're asked to find is the linear correlation coefficient for those 2 sets of data, the time and the tip amount. Going back to our StatCrunch, remember we had a bunch of information that came with this in addition to the scatter plot, and we can find that again by just clicking on the arrow at the bottom, going to the left. The R value, the linear correlation coefficient, is this value right here, R correlation coefficient. So I'm going to go ahead and just copy that number right from here and go back to my math lab, and I'm going to paste that value right there in the answer field. Before I hit submit, let's check how many decimal places my math lab wanted. It says round to 3 decimal places. That means 3 numbers should come after the decimal point. So here's the decimal point, and we have 1, 2, 3 numbers coming after it. We want to make sure we round correctly. So I look at the digit after that 3rd position. It's a 0, so that means I should round down, which means I leave this 8 as an 8. I don't round it up to 9. So let's take off the digits that we didn't need. So this is now the linear correlation coefficient R to 3 decimal places. Now we want to determine the null and alternative hypothesis. So in a test for correlation, the null and alternative hypothesis are always the same. The null hypothesis, H0, is always that rho, this is not a P, it's the Greek letter rho is equal to 0. Always, always in these tests, the null hypothesis is that rho is equal to 0, and the alternative hypothesis is always that rho is not equal to 0. In English, what this means, the null hypothesis means that there is no correlation between these 2 sets of data. So for this question, the null hypothesis, rho equals 0, in a sentence means that there is no correlation between the time of the taxi ride and the amount of the tip. And the alternative hypothesis means the opposite. It means that there is a correlation between the time of the ride and the tip. Now we want the test statistic. The test statistic T, again, is going to be in StatCrunch. So if we go back over to our StatCrunch, we should be able to find it. So the number that we're looking for is this number right here. It's the T-stat number under the row for slope. So this 0.76477, etc., is the test statistic for this particular hypothesis test. So we're going to go ahead and copy that and go back over to our My Math Lab and paste it. This one says to round to 2 decimal places, so that means I want the 0.76. The number after the 6 is a 4, which means I would round down, leaving the 6 as a 6. Next, we want the p-value. So again, back over to StatCrunch. The p-value is the number just to the right of that test statistic. It's under the p-value column. Again, we're focused on the slope row. So this is the p-value. Copy and paste. We want this one to 3 decimal places. So again, 1, 2, 3. We're going to round correctly. That one should have been rounded down. And now we want to make our conclusion. So this says, since the p-value of the linear correlation coefficient is, and we can choose either, let's see if we can get this up a little bit. We can choose either the p-value or the linear correlation coefficient is less than the significance level or greater than the significance level. So the p-value that we got was 0.473. The significance level that we were given was 0.01. So 0.473 is definitely greater than 0.01. So we're going to choose greater than. Let's remember what that means. When our p-value is greater than the significance level, what we are going to do is we are going to fail to reject our null hypothesis. In other words, we are not going to reject the null hypothesis. As far as we're concerned, the statement that was in the null hypothesis is probably a good representation of reality. This was the null hypothesis. Remember what we said a minute ago. The null hypothesis here says that there is no correlation between the time of the ride and the tip amount. And we have decided to not reject that statement. In other words, I have no evidence to reject the notion that the time a person takes a ride is not correlated to how much they are going to tip. So if we come over here, we would say there is not sufficient evidence to support the claim that there is a linear correlation between the time of the ride and the tip amounts. So it appears that the riders do not base their tips on the time of the ride. Go ahead and go back and listen to that again in the video. If you have any questions, reach out and someone will be happy to help you. But one more time, the claim here, right here, said the claim is linear correlation between the two variables. And the statement in our two hypotheses that said that there was correlation was in the alternative hypothesis. We looked at the null hypothesis, and based on our very large p-value, we decided not to reject that statement. So we said there's no reason for me to believe that these two variables are not correlated. There's a lot of double negatives in there, but basically we've essentially found some evidence for the null hypothesis, which means we do not have evidence for the alternative hypothesis. The alternative hypothesis is what said that the two variables would have been correlated, so we do not have any evidence to support that.